Orthogonality of two spheres. It means if S1 is equal to x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 is equal to 0. S2 is equal to x square plus y square plus z square plus 2u2x plus 2v2y plus 2w2z plus d2 is equal to 0. If S1 is perpendicular to S2, if and only if 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. You see, if two spheres are orthogonal means two spheres are perpendicular each other, it means the angle between two spheres is 90 degrees, then we say that two spheres are orthogonal. So what is the condition for orthogonality of the two spheres? That is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. It means first of all the given sphere equations are in the normal form. Normal form means x square y square z square coefficients created as a 1 1 1. So x square y square z square, x square y square z square, like that. So that is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. Suppose ఈ కండిషన్ సాటిస్ఫై అయినట్లయితే two spheres we say that is orthogonal to each other. Find the equation of the sphere that passes through the circle, that is x square plus y square plus z square minus 2x plus 3y minus 4z plus 6 is equal to 0, and 3x minus 4y plus 5z minus 15 is equal to 0. You see, the equation of the sphere is passing through the circle means circle equation is what? Plane equation together this sphere equation. That is the, suppose in the intersecting part of the plane and sphere is called the circle, we know. So what is the equation of the sphere here, which are passing through the circle? That is x square plus y square plus z square minus 2x plus 3y minus 4z plus 6 plus lambda of 3x minus 4y plus 5z minus 15 is equal to 0. For by some simplification, x square plus y square plus z square plus x of 3 lambda minus 2 plus y of 3 minus 4 lambda plus z of 5 lambda minus 4 plus 6 of minus 15 lambda is equal to 0. Suppose one is orthogonal to the given equation, what? X square plus y square plus z square plus 2x plus 4y minus 6z plus 11 is equal to 0. Here you see that here giving two conditions. One is passing through the circle equation and another one is orthogonal to the given sphere. Orthogonal to the given sphere means two u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. In this condition we substitute the values. What are they? One is 2 of 3 lambda minus 2 by 2 into 1 plus 2 of 3 minus 4 lambda by 2 into 2 plus 2 of 5 lambda by 4 by 2 into minus 3. That is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. According to that formula, we simplify it. 3 lambda minus 2 plus 2 into 3 6 minus 8 lambda minus 15 lambda minus into minus plus 12 minus 15 lambda go that side, that is plus 15 lambda, and 6 is equal to 15 lambda means 6 plus 11 17, 17 go that side, that is minus 17 is equal to 0. And finally minus 5 lambda minus 1 minus is equal to 0, and 5 lambda is equal to minus 1, lambda is equal to minus 5. Just you substitute lambda is equal to minus 5 1 by 5 in the given equation, that is x square plus y square plus z square minus 2x plus 3y minus 4z plus 6 plus lambda of lambda means you substitute here minus 1 by 5, that is 3x minus 4y plus 5z minus 15 is equal to 0. You multiply with 5, that is 5 of x square plus y square plus z square, and 5 into 2 minus 2 minus 10x, here minus 3x, that is minus 13x, and 5 into 3 15y minus into minus plus 4y, 15y plus 4y is 19y, and 5 into minus 4 minus 20z plus 15z plus 5z, that is minus 25z plus 5 plus 45 is equal to 0, because 5 6 are 30 and minus into minus plus 15, 30 plus 15, that is 45, that is constant. So here you find the equations. What are they? One is find the equation of the sphere. Here given what conditions are given here? One is passing through the circle and another one is orthogonal to the one sphere. By that two conditions we solve the values of lambda in S plus lambda is equal to 0. We get the value of lambda and substitute lambda in minus lambda is equal to minus 1 by 5 in the given equation. So this is one of the example to find how to find the equation of the find the equation of the sphere that passes through the 2 points 0 3 0 minus 2 minus 1 minus 4 and cuts orthogonally the two spheres, that is x square plus y square plus z square plus x minus 3z minus 2 is equal to 0. Another one is 2 of x square plus y square plus z square plus x plus 3y plus 4 is equal to 0. So find the equation of the sphere that passes through the 2 points like this. Here 2 points is given and 2 spheres are given. What are 2 points? That is 0 3 0 1. Another one is minus 2 minus 1 4. For the general formula, in general equation, what is that? X square plus y square plus z square plus 2ux plus 2vy 2wz plus d is equal to 0. In this equation we substitute 0 3 0. What we get? That is 6v plus d is equal to minus 9. 6v plus d is equal to minus 9. That is one equation. Like that, minus 2 minus 1 minus 4 belongs to 1. Belongs to 1 means lies on that line, that plane. That is 4 plus 1 plus 16 minus 4u minus 2v minus 8w plus d is equal to 0. That is minus 4u minus 2v minus 8w plus d is equal to 16 plus 4 20 plus 1 21. 21 go that side, that is minus 21. So minus 2 minus 1 minus 4 ఈ పాయింట్ సబ్స్టిట్యూట్ చేసినప్పుడు ఇంకొక ఈక్వేషన్ వచ్చింది మనకు, థర్డ్ ఈక్వేషన్, సెకండ్ ఈక్వేషన్ అండ్ థర్డ్ ఈక్వేషన్. అండ్ One is orthogonal to the given sphere, that is y square plus y square plus z square plus x minus 3z minus 2 is equal to 0. That is 2u into 1 by 2 plus 2v into 0 plus 2w into minus 3 by 2 is equal to d minus 2. What is the condition for orthogonality? That is 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus 2 d2. According to that formula, just we substitute the values. 2u into 1 by 4 plus 2v into 3 by 4 plus 2w into 0 is equal to d plus 2. So u plus 2 to cancel. 2 1s are 2 2s are 4, 2 1s are 2 2s are 4, like that. We got u plus 3v. If 2 go this side, that is 2d minus 2d is equal to 2 2s are 4. That is fifth equation. Now we got second equation, third equation, second equation, third equation, fourth equation, fifth equation. Suppose you see here 6v plus d is equal to minus 9. You take this equation with, if you solve the equation with 4, in second equation there is vd, in fourth equation that is u, w and d. If you cancel in these two equations, d is cancelled, the equation becomes in u, v and w. Okay, one equation. Like that, if you take third and fourth, in same that also you cancel the d only. Again we got u, v, w equations. You take first and fourth, second and fourth, like that. You got u, v, w. You take like that. Just you think, just you practice the techniques, and we got the solve the equations, that is u, v, w and d values. After some fresh work in the solving the linear equations, there is u is equal to 1, v is equal to minus 1, w is equal to 2 and d is equal to minus 3. But in the examination level you cannot write like this. The values is u is equal to 1, v is equal to minus 1, w is equal to 2, d is equal to. This you solve the equations and you got u, v, w, d values and substitute in 1. Then we get, that is x square plus y square plus z square plus 2x minus 2y plus 4z minus 3 is equal to 0. It means we got the equation which we have required, but here solutions is just to solve the equations, simultaneous equations, that is second, third, fourth and fifth. 4 equations is there and 4 unknowns is there. That's why we got it easily. Okay. This is the procedure how to find the equations of this sphere. It passes through 2 points, otherwise passes through 3 points and perpendicular orthogonal to one sphere, like this, or passes through 1 point orthogonal to 3 spheres. Whatever it may be, we got the 4 equations and solve the 4 equations. We get u, v, w and d values. You see, what is radical plane? A radical plane means when we want to find a radical plane means wherever if 2 or more spheres are given, then we can find only the radical plane. Suppose here you see S1 is equal to 0, S2 is equal to 0 are the two spheres. Then the radical plane is S1 minus S2 is equal to 0. S1 minus S2 is equal to 0 means, suppose the equation of S1 is x square plus y square plus z square x square plus y square plus z square plus 2u1x 2v1y 2w1z plus d1 is equal to 0. This is first equation. So for example, this is another. Second example is second sphere is 2x square plus 2y square plus 2z square is given. For can you write S1 minus S2 is equal to 0? That is the plane equation. No, that also becomes what equation? That is sphere. Again we get sphere equation here, but here S1 S2, in the S1 S2s there is same coefficients of x square y square z square. Then only we simplify it. Then radical plane is 2x of u1 minus u2 plus 2y of y1 minus y2 plus 2z of w1 minus w2 plus d1 minus d2. ఎప్పుడు వస్తుంది అంటే the equations are S1 S2 are in the same degree and same coefficients of x square y square z square. So this is called radical plane. 2x of u1 minus u2 plus 2y of y1 v1 minus v2 2z of w1 minus w2 plus d1 minus d2 is equal to 0. Subtract these two sphere equations, we got it, this one only. Okay, is called radical plane of two spheres. Then coaxial system of the spheres. Coaxial system means this is the system of the spheres. System of the spheres means two or more than spheres are there, then it will called coaxial system of the sphere. The definition is a system of spheres, any two members of which have the same radical plane is called a coaxial system of spheres. For example, you take S1, S2, S3. If you find S1 minus S2 is equal to 0, we get one radical plane. Again S2 minus S3 is equal to 0, we get one radical plane. S1 and S3 is equal to 0, we get one radical plane. If these three radical planes are same equations, same plane equations, that is called coaxial system of the sphere. Coaxial system means if two or more than spheres are given, the radical planes are same, equal radical planes, same radical planes is called the coaxial system of the sphere. So coaxial system of the sphere means thus the system of spheres is S1 plus lambda S2 is equal to 0. You see here S1 is a sphere equation and S2 also is a one of the sphere equation. S1 plus lambda S2 is equal to 0. These two spheres. And what is the radical plane is S1 minus S2 is equal to 0 is the radical plane. Then the coaxial system of spheres is S1 plus k of S1 minus S2 is equal to 0. Therefore, coaxial system of sphere in the form of S plus lambda u is equal to 0, where u is the S1 minus S2 is equal to 0. You see first here, first in first point we find the radical plane, that is S1 minus S2 is equal to 0. After radical plane we find the coaxial system of the spheres, that is a system spheres any two members of which have radical plane is coaxial system of the spheres. Thus the system of spheres is S1 plus lambda S2 is equal to 0. అంటే ఇక్కడ రెండు స్పియర్స్ ఈక్వేషన్స్ ఉన్నప్పుడు we cannot find how to find the value of lambda. That's why just first we find the common radical plane, that is S1 plus k of S1 minus S2 is equal to 0. Next we can find the what is S1 minus S2, that is a plane equation, one constant, one sphere equation plus some constant into plane equation, that is called the coaxial system of the sphere in the form that is called S plus lambda u is equal to 0, where S is whatever it may be, maybe that is you take as S1 or you take S2, whatever it may be, but here lambda is the constant which we have to find. For that, to find the value of lambda, the conditions, some conditions are given. Okay. So finally the coaxial system of the sphere is S plus lambda u is equal to 0. Okay.